Hello, everyone. Good morning, good evening. Welcome to Cloud and DevOps Batch 58. So before I start the session, I just want to give a quick recap on what's being covered in the previous session. Previous session, we were learning Kubernetes. And as a part of the Kubernetes, we learned various aspects in Kubernetes that we can learn, irrespective whether it is a Kubernetes cluster or a minikube. A Kubernetes is a Kubernetes. We just learned all these concepts, almost 20 examples on the top of a minikube cluster. Minikube is a sandbox environment which just runs a container to offer Kubernetes sandbox environment. You get most of it, but certain features you won't get it. Again, in real time, you don't use Minikube. Minikube is just for sandboxing, which is just like a testing. In reality, you use some mature systems called as EKS. Okay, EKS stands for Elastic Kubernetes Service. So remember this point, managed services for AWS. Okay, so EKS. EKS stands for Elastic Kubernetes Service. So this is a very robust and heavy lifting service. And even I saw clusters with 100, 200, 300, 400 nodes as well. Okay. And that much important is whatever the security aspects. Okay. Who can do what? Authorization. Authentication is like whether he can sign in or not. Authorization means once he sign in, what he can do. Okay, is the authorization. So all this aspect you can only see when you have a proper cluster. So advantage of using EKS is AWS is responsible for managing the nodes. Okay, you don't do Linux patching. You are not responsible for container management. Okay, you don't have to employ storage solution. Okay, and you get out of the box here. Highly available storage solution. Very nice features can be installed as optional. And we call them. So one Kubernetes cluster can have a number of node pools. So what is a node pool? We already discussed. A node pool is nothing but a group of nodes. Okay. A node pool or a node group is nothing but a group of nodes. So you can say T3 dot medium. You can have one more node pool with a T3 dot medium. Okay. So you can have one cluster with multiple node pools. Okay. Now, remember one important point. This is a very important point. What will happen if your master node is gone or down in a Kubernetes cluster? Okay, this is a very important thing to know. First thing you need to understand, in managed environment, we won't be just to master node. Okay, technically, because if Amazon promises you some sort of performance, and if they give you the access to the management node, you tune it as per your requirement, and Amazon promised performance cannot be delivered. Okay, that is one thing you need to remember. Okay, keep this point in mind. You never have access to the master node. Okay, you cannot access this. It's in AWS control, which makes sense. Second thing. Okay, if master is down, you cannot schedule new workloads and you cannot connect to the cluster. Why? Okay, because Cube API server, etcd database, scheduler, and controller manager run master. Okay, so the existing workloads will run as is. But if any of the pods of the deployment were killed, then new pods won't be coming up. Come up because Cube API server and scheduler are not there. Okay, this is a very important point. Clear? That's the reason typically in companies what we do is we go with a multi-node cluster. Okay, so what exactly does this mean? So what does this mean is you will have more than one master. You can have multi-master. This way, even okay, almost all the production grade clusters you use multi-master based approach. So this way what happens is this master one will be hosted in zone 1A and master 2 will be hosted in zone 1B and master 3 will be hosted in zone 1C. So that three masters will be scheduled across three different zones. Okay, even if you lose, the other one will be there to honor the workloads. All right. Okay. Keep this point in mind. You can have n number of node groups. Yeah. Okay. You can have multi-master Kubernetes cluster to honor the to achieve HA in case of master failure. All right. Clear or not? Any questions, guys? Any questions? Okay, you never use either you use one or three, you don't see two. Okay, so let's go ahead and try to create a Kubernetes cluster because we need to learn some advanced concepts, right? That is such. And to learn this concept of security, role-based access control. Who can do what? Not everyone who sign into the cluster or who connected to the cluster can do everything, right? So operator just should have read access. Engineering team should have write access. Admin team should have everything access. And your manager should have your access. Security team should have secrets access. So based on the role that you're being a part of the organization, you should get access. Okay. So yeah. And role-based access control, network security, okay, container and pod security, you can achieve all of these things only when you have a managed service like this. Okay, let's try to create a Kubernetes cluster manually first. And again, keep this point in mind. EKS in AWS takes 15 to 30 minutes of time to create. Okay, so how to create cluster. Okay. First, create the cluster by selecting the version of our choice. Next, create the node pools. Those are node group with the instance type of your choice. And these nodes can be spot or reserved or on demand. So in a lot of companies, what typically people do is, for example, if you take this as a Kubernetes cluster, Take this as a Kubernetes cluster. This is a master. And if you need 10 nodes, what typically people do is they create 2 node pools. Okay. So here you call it as a node pool 001. Spot instances on demand. Okay. So you can say all the instances that comes up here are t3.media. Again, what type of node is based on the type of workload that you're going to host. It's purely your choice. Okay, done. Now what we are going to do is we apply 60-30 principle, 60-40 principle. Okay. 60% of the nodes are on demand and 40% of the nodes are spot. This way you can save cost. 60-40. This is a cost saving strategy where all the nodes that comes up here okay. All right. So this way, at any point of time, the promised nodes at any cost, they will be there. Okay. Demand, right? At any point of time, they will be there. These may or may not may go down at some point of time. Even if they go some point of time, there are other nodes which are ready to take the load. So that's the reason we'll also make sure workloads will be distributed across the both the node pools. Okay. So the cluster is one, the node pools are two. All right, guys. So this is another strategy. So also you can also have more than one master node. You can also have more than one master node. Is just to make sure in case if you lose the masters, still there are two more masters to accommodate the load. Okay. Let's try to make sure we have this in place. It's not your headache, by the way. Amazon takes care of it. Just using different colors to signify this. But again, you get everything at cost. Okay. It's not just like, okay, Amazon offers everything out of the box. No, you need to decide what you want. Okay. For non-production gut cluster, it doesn't make sense to honor 3 boxes. Okay. So it's all about the trade-offs, what you can afford versus okay, highly available. Kubernetes cluster with a multi-master, multiple masters. All right. Okay. let's talk about other aspects. Let's talk about RBAC, and for that, we need to have a Kubernetes cluster. So first, you need to create a Kubernetes cluster. Okay. So you need to mention the Kubernetes cluster name. You can mention it as a sample. Again, you have a lot of steps to go through. Okay. So you can mention the Kubernetes cluster as B58-S54 learning. Okay. And for this Kubernetes cluster, this cluster has to go and talk to the AWS account. Okay. Then only this cluster can create the nodes. That means this should be having the appropriate roles are needed for the cluster. Because this cluster, once it is created, it has to create the compute nodes, right? So it should have compute access, and at the same time, it should also have the node access. Now, which version of Kubernetes that you want? 1.31, 1.30, or 1.29? So you don't have to aggressively go with a brand new version. Okay, so maybe you can go with a 30 or 31, anything of your choice, by the way. And upgrade policy. Okay, there are two types of upgrade policies. So in Kubernetes, typically when a version is released, it goes to the next version. Okay, they say that, okay, when a version is released, okay, if you look at this, when a version is released, they tell you, okay, if you are using 1.29, it will be end of the support by March 2023, 2025. That means next year by March 23, it will be end of support. Then it goes to the extended end of support. So when it goes to the extended support, you need to pay for the support that Amazon offers. So that's the reason for every 6 months or every 3 months, you upgrade the cluster from one version to other. Typically in organizations, okay, we don't go with this. We only go with this if you have some applications that are not compatible with version 30 or version 31. If you go with extended, then Amazon stops supporting a specific version. So they support 14 more months or 17 more months extra. But from that point of time, you need to pay extra for the support Amazon offers. Okay, typically we go with the standard support. So whenever Amazon releases a particular version of Kubernetes, they're gonna support this product as a standard maintenance for the next 14 months. And if it's completed by the 14th month, if you have not upgraded your cluster, they will be forcefully upgrading it. Okay, and Bootstrap administrator cluster. Hello, cluster administration access for IAM role. This is a suggested option. And cluster authentication mode, whether you want to go with EKS API of your choice. So typically just go with this. And then you want your secrets that are stored on the top of this cluster to be encrypted. Okay, so you can create keys. Okay, these are the keys that helps in managing the encryption of the secrets that you have stored. So next, okay, you need to select where you want this to be created. And keep in mind, if you are in North Virginia, only A, B, C, D are supported, E is not supported. So make sure if you select this, E is not there out of the 6 availability zones. That is as per some setting, they are not offering for the free tier. Okay, maybe that is overburdened with already existing customers. All right. So subnet group is nothing but a group of subnets that are being offered. So that means your nodes that are provisioned will be provisioned across this. For example, if your organization subnets are on 1, 2, 3, then there is no point in selecting this. Okay. So your network is provisioned only on these 3 subnets. You can next to select the security group of your choice. Okay. And then cluster IP address family IPv4. And you can also define the network range for your for your master network. I don't want to do that. And again, in AWS, the cluster endpoint is of 3 types. Okay, keep this point in mind. In AWS, EKS offers three types of clusters with respect to connectivity. Okay, first one is public cluster, which is not at all used in production. Next is public and private. Next is private cluster. So what exactly does this mean? Okay, so first we'll go with this. So this means if you want to access the cluster, the user should be in the corporate network or in your company network. Private cluster means, okay, the cluster endpoint is only accessible through your VPC. Worker traffic to the node point will stay within the VPC. Okay, VPC is nothing but your network. So when a cluster is private, okay, assume this is the EKS cluster. Not assume this is an EKS cluster. And this is the network. Okay, so if you want to access this, okay, this is your network, intranet. Intranet is nothing but a private network or a corporate network. So if you want to access this Kubernetes cluster, you have to be within the network. Okay. To access this cluster at any cost, you have to be within the network. Okay. So if you so this you are already in the network, you can only access the if this cluster is private, typically in organizations, this is how it will be. You can only access the cluster if you are in the network, and the communication between the master nodes and the worker nodes is strictly private within the network. Okay, so this is a very important point. Next. Next is public cluster. So this means this public cluster and private cluster, let's also talk about it. So here the public cluster, okay. So this public cluster means you can access this master from outside the network as well. And at the same time, the traffic between the master and this nodes may or may not be within the network. It goes outside the network, come inside. Okay, that is called as public network, which you don't see in any of the times in the corporate network. And next is private, public and private. You can access the cluster from the public network, but the communication between master and the nodes is within the VPC or within the network. Okay, that's what we are saying. So typically in organizations, you don't even go through public and private. All right. It's very important, very important to know. You can introduce this. These are very commonly asked. Okay. So, but don't even say that, okay, we are using public and private cluster in my organization. No, it's strictly private. Okay. If you want to connect to the Kubernetes cluster, you should be within the network. Your nodes and master will communicate only within the network. Okay. This is another thing that you next thing is, and once it is created, okay, you also need to, you can also enable Prometheus, send Prometheus metrics to Amazon, manage a Prometheus service. So by default, out of the box, you get Prometheus configuration out of it. Okay, you can also mention what are the scraper configuration and all these things. Okay, so you can configure. Earlier, we did these things manually, right? You can define the configurations of your choice. So next, control plane login. What logs needs to be tracked? Okay, whenever some transaction, whenever some event happens, okay, every action will log an event, and where all these logs should be captured. Okay, I want API server logs to be captured, and auditing logs to be captured, and scheduler logs to be captured. Okay, so if it is a sandbox cluster, you don't have to enable all of this, because end of the day, everything enabling logs is going to cost a lot of money. And then if you want any sort of account, you can select. Okay, so core DNS, kube proxy, AWS VPC CNI, AWS EKS pod identifier, and keep this point in mind. If you want uh, if you want networking features in AWS, you need to use the networking solution called as AWS VPC CNI. CNI stands for Containing Networking Interface. It's a networking solution on Kubernetes. Okay, so AWS VPC CNI. What is the networking solution offered on AWS? AWS VPC CNI is the networking solution that can be enabled to get pod and service level restriction. Okay. So for example, you want to implement a policy where pods that are running, okay, for example, namespace. Okay, if you want to implement a policy, by default, workloads that are running in this namespace can talk to this namespace can talk to this namespace. If you want to implement a networking policy where only catalog shouldn't be talked to payment, but cart should be able to talk to payment, and payment should be able to talk to cart. Okay, so catalog shouldn't be able to talk to payment, or payment shouldn't be able to talk to catalog. This is just to make sure to reduce the blast radius. So if some catastrophe happens, if someone tries to hack your catalog service or catalog namespace, if they are given access to this, and they can connect to the payment, which is a mission critical thing, and they can destroy it, right? So this is to make sure who can, I mean, it's just like not everyone in the cluster can talk to everyone, right? So it's just like I can impose restrictions, network level restrictions, that one namespace object cannot be talked to other namespace object, or this pod cannot be talked to this pod. This pod can talk to this pod, but other way around it shouldn't work. If you want to implement these complex networking strategies, you need to have a CNI in place, Amazon CNI. What is the default AWS VPC CNI that comes up in EKS? AWS CNI. Okay, CNI is a networking solution in AWS. All right. Clear? Any questions so far? Clear? Am I audible? Anyone? Can you confirm me? Am I audible?
Yes, Manoj, audible.
Are we clear?
Yes, myself is clear.
Guys, any questions? I'm taking a pause to hear if you have any questions. Okay, let's proceed. And then you select whatever is needed. And AWS guard duty is a very nice feature, guys. So when you enable the AWS guard duty, what happens is it uses artificial intelligence to identify what is legitimate traffic. So once you deploy your cluster and deploy your workloads, you try to understand the usual patterns, usual workflows, how which call is happening, what is the flow, at what time requests will be high, at what time requests will be low, which pod talks to which pod, which service won't talk to which. So it tries to observe all these things. And if something it finds as anomaly, that means if something it finds unusual, it is going to immediately report that. Okay, again, it comes as an add-on, so you need to pay for it. Okay, so it's a very nice feature. So AWS EKS pod identity agent. Okay, so if you install this, the pods, okay, the pods that are running in Kubernetes can talk to the services of AWS without the need of keys. Just like if my pod wants to talk to S3 bucket, or if my pod wants to read the data from the Route 53, you can use AWS Identity Agent. Okay, so next you need to select next, and then just to verify what it is needed, and then next. All you need to do is just create. It's going to create the cluster, and that will have these three DNS. Okay, core DNS, VPC CNI, all these things. Okay, make sure you install VPC CNI. If not, most of the networking features won't work. All right. So what are the other networking solutions? Okay, what are the other networking solutions that are supported by Kubernetes? Okay, Calico, Calico CNI, ViewNet. Okay, these are the different networking CNIs that are supported. So Kubernetes CNI providers. Okay, so container network interface, network plugins. Yeah, come here. Loopback CNI, support host port. Okay. Mm, Calico CNI. Okay, so Calico is a CNI, control network container network interface, and VNets is also a container network interface. So these are the different things. Okay, so but in AWS by default you get an option, just with a click of a button you will get this networking solution. Okay, where you can implement complex solutions like don't talk to this guy, allow this guy talking to me. Okay, so you can enable the communication level policies between them, and then you create this, and then you need to create the Kubernetes node pool. Okay, but I don't want to go through this approach of creating it manually, because we were aligned to go through the Kubernetes we are going through a no code approach. So we'll deal through Terraform only. Okay, we can go with manually. Okay, let's try to create Kubernetes, yes, using Terraform. Okay, so we'll do it. All right. So what we can do is, so you don't have to memorize. We already know Terraform. Let's see what we can do. Okay. Now what we can do is just say registry. Okay. All right. So do you have any modules? Okay, we can directly consume the modules. Okay, so these modules are ready-made modules. You can directly just supply the values. You get out most of it. Terraform, AWS, EKS. All you need to do is just need to copy this and just use it. Okay, you just need to copy this. Okay, you get the code from the external party. I mean, which is nothing but the source. You don't have to write anything. So the code is already available. All you need to do is just need to change the values. Okay, so it's very simple. You don't maintain the code. All you do is apply the variables. But if AWS releases any new features, and if that particular option is not available in the backend code, it is not supported. And that's the reason we frequently upgrade from one module version to another module. Okay, all we need to do is just call the module and supply the value of your choice. Okay, but if you're not caring about it, okay, again, to start learning, this is sufficient enough. But to see things at production, we build our own things. Okay, so unless until if things are extremely complex and if they are not supported well, if you do it manually, if not, we create things by our own. Okay, since we know Terraform, there is no point in going through this. So maybe what we can do is AWS EKS. Okay, I want to create the resource. Make sure this is an official provider from HashiCorp. Okay, HashiCorp in collaboration with AWS has built this, so it is a certified product. So AWS EKS cluster. Again, if you see this, why the hell do I need the role? Because for the cluster, once it is created to create the nodes, it should have the needed roles. Okay, maybe you can copy this. Okay, let's create EKS. I'll show you how quickly we can do it because we know Kubernetes already. Okay, and if you look at this, it needs some roles. Okay, and we need to supply the subnet IDs. Okay, and then it needs to have some roles. So we also need to create these roles. Where do I get these roles? Okay, so here if you look at this the role dependencies also, that means this role should also be there. Okay, if you scroll down, there are some policies that are already there which are relevant to this. Okay, so maybe you can just copy this and they can build it here. Done. Okay, perfect. If you look at this, what it is doing is, uh, if you look at this, it is creating a role, and then for the created role, it is attaching a policy, and the name of the policy is cluster. That means for this role, you are attaching a policy. That means you are binding the policy. That means you are creating a role, and for the role, you are adding the privileges, just like creating an AM role and adding admin privileges, and then okay, you are attaching the policy attachment, and then what you're doing, AWS IAM policy attachment, okay, for the policy that you have created. So you have created a role and attaching two policies for it. Okay, one policy is AWS EKS cluster policy, and another policy is AWS EKS VPC controller manager. Okay, and for this, if you see AWS IAM role example, and you, okay, that means this role is going to be, this policy is going to be attached to this particular role. Okay, it's creating a role and two policies. That's it. Now, let's apply these two subnet IDs. Okay, let's not complicate it. We can dynamically get that, but I don't want to go there. So go here. The VPC is a network service. We'll see the networking concept in the next week. So come here, select the VPC. Make sure you're in the North Virginia. The network is also North Virginia. By default, you can ask me, we have not created any network all these days, how we are using it. AWS offers you a default network by default in each and every region you select. We are using it. Okay, in corporate, we build our own network. We'll also build our own network. So here, these are the subnets that it offers. Okay, you can come here and see. So subnet 1, 2, 3, 4, 5. These are the subnets that it offers. And if you want to see where and all it is supporting, just telling what to be displayed. Okay, if you see this US East, don't choose E. So I'll just choose A, B, C, US East 1, A, US East 1, B, US East 1, C. So I'll just copy this. Done. Okay, you need to choose the network from your network, okay, from your account. And if you copy mine, it will not work. All right. Network info we are supplying. That means this is where nodes are going to be provisioned. Okay, that means this is a multi-zonal Kubernetes cluster. That means even if you lose one zone, your nodes are still operating in the other zones. Okay, network information we have supplied. Okay, we can also use the data source. We can fetch it dynamically, but I don't want to get into that. Okay, keep in mind the network we are using is a default VPC. So we are supplying the both the items. So next, what's next? So the name of the cluster is example cluster. Done. Yes. Then role. I am role done. And then uh, so this depends on is like this is making sure you create the cluster. Okay. See, this means I don't want you to be created first. Okay. I want to make sure these should be there in place before the cluster to be provisioned. That means we are creating a dependency. And then so it is just like outputs we really don't need. Okay, this is creating a cluster. And then this is just like assuming the role STS session token service. So creating a role and attaching to it. Uh, Anything else? Okay, done. Once this cluster is created, we also, okay, first let's publish it. Okay, I want to see whether it is working or not. I just don't want to assume things. Let me clone it. Okay, cd to learn. Okay, git pull terraform init. Okay, hold on. I also need to supply the state, right? Let me do it. State.tf. I don't have to worry. I have everything in place because we already a pro in Terraform. Remote state my.tf. Done. I also need to supply the provider, right? Okay, and this one I'll check EKS. Done. US-east one. Anything else? Okay, that's it. Publish. Okay, again, cluster provisioning is gonna take 10 to 15 minutes of time. Okay, you should have patience. That is a bad thing with AWS EKS, by the way. If it's Azure or GCP, cluster provisioning is just 2 to 5 minutes of job, but it's gonna take a lot of time, lot of time. Okay, so it's initializing. So quickly recapping, when you make an initialize, what it's going to do is first it's going to make sure whatever the code that you have written, okay, is it going to be downloading all the plugins that are mentioned, and then it is also going to validate whether the code that you have written is correct or not. And at the same time, if you are using remote modules, it's also going to clone the needed code as a part of the initialization. So these are the three things that it is going to make. Okay, and if you see this, the name of the cluster that we are creating is, okay, EKS B58 EKS. Now, if you come here and if you try to see this, if you see this B58 EKS is creating. So as I mentioned, it's going to take a lot of time, 10 to 15 minutes of time. So let that create. Let that create. And I also want to make sure I told you in the beginning itself, I want to add CNI. Okay. AWS VPC CNI. So this is something I would like to enable it. Okay. By default, you will get the cube DNS. If you don't want cube DNS, if you want core DNS, you can use this option. So, so yeah. And if you are using shared disk, okay, where the disk has to be shared by multiple pods within the cluster, in that case, you can go with EFS, container storage interface. These are the different plugins, okay? So again, this one I would like to go through code, okay? Mm. Let's build it manually, okay? Because I know it's gonna take a lot of time. So in the interim, what I'm gonna do is I'll go ahead and try to create a node pool. Okay, so node pool or node group, both of them are same. In Google Cloud, we call it as a node pool. In AWS, we call it as a node group. But yes, fundamentally, both of them are same. Okay. So resource AWS EKS node group. Select this resource. Okay, so let's copy this. Provisions, node group, and attaches this. Oh, make S. Uh, so node group name. Let's try to give something that makes sense. And be on demand 001. Okay, maybe I'll say spot 001. I want to make sure that the cluster that we are creating will have the nodes spot, because costing, I'm quite sensitive about costing, and subnet IDs, okay, where these nodes are to be created. Here, this means where the master nodes have to be created. Keep this point in mind. So here you're defining where the master node should be there. So here three master nodes will be coming up. I'll be using the same subnets. Okay. I also want my nodes should be in the similar network. Copy this and supply. Done. Now, so what's next? AWS EKS.cluster name. So you are creating a node group and you're attaching it to the cluster name and node group name and node role ARN. So AWS IAM role example, I think this example is already there, right? So you need to use something else. And these are roles for the cluster. Okay. Now you also need to have the roles for the cluster. Right, not cluster, for the nodes, right? So you need to have your own IAM roles. So AWS IAM role example.arn, no, you shouldn't be using it. And here, what is the size of the cluster? This is a very important point. Okay, so what can be the, when workload increases, what can be the maximum number of nodes? Number of nodes that the node group can scale. Okay, decide when the cluster was provisioned, this would be the node group count. Okay, so minimum size is like when the workloads are really less, this would be the number where node group can scale down. And again, this is very commonly asked question. What is the difference? Max size, anyone can answer what is the max size. Okay, what is the minimum size? But when it comes to desired versus minimum, people get confused. Desired means when you're provisioning the cluster, what is the minimum number of nodes that the cluster to get start with? Minimum is like when there are no workloads, what can be the minimum that it has to scale down? Okay. Hmm. They are really not needed. I'm just commenting it out. Whatever these are needed, where do I get it? Oh, wow. It's created just within 6 minutes. All right. So AWS EKS IAM role for node group. Okay. All right. Maybe I can use this. And these are for IAM roles for node group. Done. So let's try to keep it simple because you are already having a role. If you look at this and you're using the same name example. So let's try to use something else. Okay. I'll just say node hyphen example. Uh, this is just creating node group example. And what is the policy that it is going to assume? JSON decode done. This means once the policy was released, and then I am creating this node policy for this particular policy, particular role. Done. Okay. uh, and this particular role, see, all you did is you created a role, okay, and you're attaching policies. Okay, I want some policies. Okay, having a role doesn't make sense, right? Because I also need some permissions. You're attaching the permissions to the policy, to the role, and then this role will be used in the node group. Okay, so we need to associate this. So how can I associate this? How can I associate this? So this is where you need to say, so node group, node hyphen example. ARN stands for Amazon resource name. So we created the role, we attached the policies, and then we are attaching that particular role to this group. Okay. So yeah. So subnets also something we have mentioned. Mm, also say three. But where can I mention? Again, I don't need this, by the way. This unavailable configuration. I don't need this. I also don't need this depends at this point of time. Uh, where can I mention the node type? Mm, instances type. Do we have anything for instance type? Yes, instance types. So list of instance types associated with the EKS node group. Okay, if you don't mention anything, T3.medium is the one that it comes up. Terraform will only perform a drift detection if the value is provided. Okay, so in instance types, you can mention a list of instances. That means a node group can have multiple instances. All right. Where do I mention that? Instance types. Just go with, and I also want to go with T3.large. I know they're gonna cost me, so I don't want to entertain it. So I just want to see whether do I have any spot type or not. So capacity type. So optional type of capacity associated with the EKS node group. Valid values are on demand or spot. Terraform will only perform the drift detection if the value is provided. By default, it is on demand. So I'll just go with spot. Done. Spot, right? So you're telling I wanna get the nodes which are spot. Okay, so I choose them spot. Uh, so and also every day, I don't want to come here and try to run this manually. So what I can do is I'll just come here and say bash create.sh. You can destroy.sh. So what I can do is if I run git pull terraform init, Terraform plan. Okay. And if I want to destroy, I can also do the same. I don't need plan when I'm destroying it. That's it. Okay. So publish the code. Perfect. So whenever I want, all I do is bash create.sh. So it's going to make a git pull and then Terraform init, Terraform plan, and Terraform apply -auto -approve. Now it's also going to create the one second, one second, one second. So how can I say it has to create CNI as well? Where do I mention the CNI? How to mention that I want to have a CNI? Okay. Uh, so how can I mention this as well as a part of the cluster? How can I give that? How do I add it? Mm, 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 mm. Because any option, CKS, CKS. Yeah. Okay, perfect. So manages this. Yeah. So this is what I want. I would like to enable this add-on. Okay. This enables the add-on. Okay. This enables the VPC-CNI. Now I want this to be coming up only after the creation of this. Okay. So it depends on. All right. Now I also want to make sure this comes up only we have it. Okay. Depends on. Okay. What does this mean is I am telling to my node group, okay, you only come up, okay, you only come up once the this one is created. Okay, so I'm quite sure whenever this is getting created, it checks okay whether the CNI is enabled or not. If CNI is enabled, then only it creates. Okay, so CNI has to be enabled on the cluster first, and then node rule provisioning. Done. Perfect. Okay, perfect. Publish it. Let's see. I'm just expecting it should work without any issues. Okay, if you see this, okay, if you look at the first option, it tells that this option is deprecated. That means you don't have to use quotes. Okay, that's what it is telling. So it is warning, not really an error. Okay, whenever Terraform moves from one version to another version, they try to deprecate certain things, they try to propose certain things. Okay, it's as a part of it. Okay, but if you're seeing warning, that means don't use this or try to remove the quotes. That's what it meant. Okay, now if you see this, it is just, and if you know this, right? So first add-on is creating, and once add-on is created, then the node cluster is coming up. Okay, so you can clearly see this add-on creation is completed. You go here, and if you try to detect this particular cluster, okay, you try to make a refresh, you can see this particular VPC CNI is enabled. What is the default? What is the CNI that is used in EKS cluster? So AWS VPC CNI. So what is the purpose of CNI? It enables networking solution. It is a networking solution that offers us complex networking capability. Okay. So yeah, let's do it. And it should be fairly quick, by the way. It shouldn't take more than 2 to 3 minutes of time. Let's do it. Let's do it. So guys, I'm giving my best, okay, to make sure we cover things with needed basics. Make sure you get to the best, okay? Okay. Now it has asked us, hey, don't use this. This is not a recommended option. Okay. Well, what it is telling is in this context, references are expected literally rather than in quotes from Terraform 0.11 earlier and okay, and earlier quotes, but reference quotes are not deprecated and will be removed in a future version. So this is a warning. Whenever you are moving from Terraform one version to another version, okay, so you get these warnings. Okay, that time what we do is we just get rid of them. Okay, we update them. All right. So okay. Now you publish it. I try to make a git pull. Again, you don't see any difference by the way, but you would be missing this warning. Okay, that's what I meant. That's right. Okay, there are no changes, but if you look at this, the warning has been gone. Earlier you're getting the warning, right? Now the warning is gone. Okay, so any other questions at this point of time? So, and one more thing, if you look at this, it has taken a lot of time, right? So going forward, what I'm going to do is just before coming to the session, I'll just say bash create 15 minutes before the session. So I'll get the cluster ready. I'll do whatever I want. Okay, clear. Any questions? Okay, perfect. So let's get to, we have the cluster. So what's next? So let's talk about RBAC. Okay. So what is RBAC? Let's talk about it. Role-based access control is a method of controlling to access the Kubernetes resources based on the roles assigned to the users or a group. A group is nothing but a human user. Group is nothing but a group that helps in adding the users to the group so that we can delegate the needed permissions to the group. Like all the team ops group should be given read-only access. Engineering team should get all the access. Admin team should get the administrator level privilege. Okay. So this helps you in doing it. So let's try to write it here. Not back. Role-based access control. Okay, role-based access control is a method of controlling access to the Kubernetes resources based on the rules. Okay, who can do what? Okay, so it's not like, okay, I connected to the cluster, I can do everything. No, that's not how it works. Okay, this helps in achieving least privilege principle. Okay, this helps in achieving least. All right, so we'll focus on this once. Okay. Any other questions before I proceed? So every day I don't have to go through all these options. I'll just type whatever I want. I can simply connect. Okay. So how do I connect to the Kubernetes cluster? Okay. First, let's try to connect to the cluster. So how to connect to Kubernetes cluster? Okay. We need to generate the kubeconfig. Okay. In our case, AWS EKS update. What is the name of a cluster? Uh, B58 EKS, right? Now this goes to the Kubernetes cluster and then, okay, it went to the Kubernetes cluster and generated the kubeconfig. Can you see this? So this is the data. Okay, and if you look at this, what exactly happened is it is running some command. Okay, it is running a command called as AWS, and it is connecting to this particular API, and it is applying these arguments region as this, east as this, EKS, and it is asking to get the token. And okay, from where I have to get the token? From this particular this. But in the which format? In the JSON format. Okay, and that particular data is available here. Okay, so technically it is running an AWS command to generate this cert file. Okay, this token. All right. Now what I want to now we can do now first let's see we got the file kube control alias kc is equal to kube control. Okay. Kc. So we connected to the cluster. Kube control command not found. Oh, we have not installed kube control here. Okay, that's fine. Install minikube. Oh, we would get this issue soon. 6 GB is free. What I can do is this is which partition. Just making sure. Cannot be grown. Okay. It cannot extend beyond. Okay. So let me fix this. Okay. I'll just add 5 more GB. And if you see this node came because there is no load. It's just running with one cluster. Okay. Go here. Storage. Just add 4 more GB. Okay. Okay. Now you got the 37 GB. If you type the VGS, you can see 6 GB is free. Earlier 6 GB. Now what I would like to do is I just want to run this. Okay, now it got expanded. I'll extend 100% of the free. So whom I want to extend? I would extend this root VG volume, right? Root VG volume. Then it's home, right? 96% is used. Okay, I'm just expanding it. So it's changed it from 6 GB to 18 GB. Okay, DFFNH. Now you can see home has 18 GB and this has 6 GB. Perfect. Now you don't get into any sort of issues. Next thing, what's next? Okay, where did we left? Okay, we are talking about RBAC, right? Uh, I also need to install keep control. How do I install keep control? Sudo done, done. Okay, now it's connected to the Kubernetes cluster. You can see Kubernetes control plane is running on this particular node. Okay, and core DNS is running on this particular node. Okay, so yeah, to further keep control, cluster info, get nodes. You can see this is the worker node, and you don't be having any sort of visibility on what do you call any sort of visibility or any sort of thing on the top of the Kubernetes master node. Okay, this is a very important point. So let's try to deal with this. Okay. Next, I also want to install. Okay. Next, to get the metric level information to gain metric level information on PKS, we need to have metric server installed. And I would like to do it as a part of the cluster provisioning. Okay. How to get the metrics or saturation info of the nodes and pods. Okay, to gain metric level estimate, okay, you need to have this. So they have their own version, by the way. Metrics server. Okay, quick question. Why am I installing metric server? This question is to Rachit. Rachit, why am I installing metric server?
To monitor the utilization.
Perfect. That's it. All right. Did we cover this topic already?
uh, Yes, actually.
Okay, perfect. Good. Okay, install. Hmm. Uh, okay, components.yaml. So maybe we need to have this information. Okay, done. So what I would like to do is I just want to metric server. Okay, for this to work, you need to make sure you connect to the cluster, right? So AWS EKS update kubeconfig. Okay, so this connects to the cluster and see this. Okay, let's see how it works. Publish to create. Now this also connects to the cluster and it's also going to install the metric server on the top of it. Let's wait for it. What Terraform init does, Terraform is it go in Terraform init is going to initialize the backend and it's going to initialize all the needed provider plugins. Okay, so three things Terraform init is going to do. It is going to initialize the backend. It is going to initialize all the mentioned plugins in the code, and at the same time, it's also going to initialize the backend modules if you are using. Okay, Terraform has compared, and there are no changes. That's fine. Okay, now if you look at this, it has done. It has connected to the Kubernetes cluster. Did it really do cat create? Okay, PC get pods. Okay, KC get pods hyphen A. Metric server should be installed. Click control apply hyphen I. Um, okay, why it didn't install? Oh, initialize them. Is it really connecting and doing? Let's check that. Get connected to the cluster. Perfect. Last time it didn't work. And if you see this, it has created something called a service account. What is this? I don't know. Okay. So here is the output. In this, what all we don't know, we'll take a note. Okay. What's next? See, we don't know what is a service account. Okay. We don't know what is a service account. We don't know what is a role. We don't know what is a cluster role. We don't know what is a binding. We don't know what is a service. We know service. So we need to know a role. role binding, service account, cluster role, cluster-role. So here are the three things that we need to learn tomorrow. Okay. So, and yeah, by the way, first let's see whether we got the pods or not. I want to make sure, yes, we have the metric server running. Now, uh, I can say AC top pods -a. When you see, you can see what is the CPU utilization and memory utilization. You can also see KB top nodes. You can also see out of the available nodes, 36 cores are utilized, which is nothing but 1% of CPU. Out of 5131, only just 15% of the memory is used. It's not historical information, it's a dynamic information. Okay. So I think we're already almost on the top of the schedule. So we'll see RBAC tomorrow. Okay. All right. So it's very simple now. Whenever I want, I'll just come here and I'll just destroy it. Okay. So for example, bash destroy.sh. That's it. We don't have destroy.sh. No such file. What the hell? Oh, there is some space. Okay. All right. All right. Perfect. Bash. Okay. Now it's also going to destroy the whole system. And maybe I can also include something called as init0. Okay, this is going to run this init command. It's also showing to shut down my workstation as well. Okay, this is another enhancement. All right, any other questions? So with this, we can prove that we know Terraform as well. With given things, we can build things of our own. All right, clear? Hold on. Clear? Any questions? It's always better you segregate them so that you don't have to run behind the things. So this way things are absolutely isolated. Other than just a backend. That's the right word. Okay. Any other questions, anyone? I know we are on the top of the schedule, so just taking a hard pause. Any other questions, anyone? Any other questions? Any questions? Rachit, any questions? Srilata, Arun David, Rachit, Girisha, Ambit. This is just to prove, even if in your organization, if you're using some private cloud, you know the resources, you can easily create it. Okay. Okay. All right. I'll take it as no. So tomorrow I don't create the cluster in the session. 15 minutes before the session, I'll just run it so that I'll get everything. Okay, that's it. That's for today. We're going to meet tomorrow in the session. And thank you. Signing off.